Hello guys, few of you did not understand the last example I did, so I thought of giving a review on this. So if you have understood this problem very well, then you can skip this video. So let's start. So we had these two functions, f of x and g of x. So the f of x was tan hyperbolic of ln x and g of x was 2 sine x minus pi by 2. And we had to plot these two functions in a single graph for minus twice pi to twice pi. This was very easy. And then we had to find the limits of the integration for the region enclosed by the curves for minus twice pi to twice pi. And then we had to find the area of the region. So some of you did not understand what the region enclosed by the functions is. So let's understand our regions first. So for the area of the region enclosed by the function, so we have two functions, f of x and g of x. So the blue one is f of x. If you see the blue curve, you can see the blue curve, this is f of x, and the orange curve, g of x. So the g of x is this orange curve, this one is g of x. So what are the regions? What are the regions enclosed by these two functions? So we have actually three regions that are enclosed by the functions. So let's look at that. So this is our first region, region 1. So you can see the space between the two curves. This space is called the region enclosed by the two curves. So we have to find the area of this region. So the enclosed region is the space between this orange and blue curve. Again, for region 2, you can see there is a space between this blue and orange curve, and this is our region 2. So this region is enclosed by blue and orange curve, and again there is another region that is enclosed by orange and blue curves. So we have to find the area of these three regions, and we have to add them to find the total area. So let's look at this again. This is our region 1. We have to find this area of this region, and again we have to find area of this region 2, and again we have to find this area of the region 3, and then I will add this 3 area to find the total area. So let's look at the formula now. So we have these two functions of x variables from minus twice pi to twice pi, and there are three regions. So to integrate, we have to integrate with respect to x, because these are functions of x variable, and the lower limit should be the left intersection point and the upper limit should be right intersection point. Since we are integrating with respect to x, so we only need the x value of the intersection point. So for this region 1, this is the left intersection point. So if you right click on the graph and choose get coordinates, we can see the coordinate value of this intersection point. You can see the x value is minus 4.2, and we only need the x value. We have to set the x value as the lower limit of this integration. So if you are integrating with respect to x, take the x value of the intersection point, and then you have to find the right intersection point, which is the upper limit. So to find the right intersection point, so this is the right intersection point, which is minus 1.8. So you have to take the x value. So you have to integrate from this minus 2.4 to minus 1.8 for region 1. So we have seen the intersection points for our region 1. So let's now look at what we have to integrate. So we have to integrate top curve minus bottom curve. So some of you were confused how you can find the top curve and bottom curve. So for these two intersection point, for region 1, we have to find the top curve and bottom curve separately. So if you see, this orange one is at top and the blue one is at bottom for this region only. I'm talking about region 1. So to find the area of this region 1, we have to integrate top curve minus bottom curve. So if this blue curve look up at this sky, it will see the orange one. So the orange curve is at top of the blue curve, and in the orange curve looks down, it will see the blue curve. So the blue one is at the bottom. So the blue one is f of x, so f of x is the bottom curve, and the orange one is g of x, so g of x is the top curve. So for region 1, we have to integrate g of x minus f of x. So what about the region 2? So again, for region 2, we have to find the intersection points first. So this minus 1.8 is the left intersection point of this region. So you can see that we have to integrate from left intersection point. So for this region, the left intersection point is minus 1.8 and the right intersection point is plus 1.8. So you have to integrate from minus 1.8 to plus 1.8. And again, for this region, which one is the top curve and which one is the bottom curve? So if the orange one looks up at the sky, it will see the blue one. So the blue curve is top curve here, and the orange curve is the bottom curve here, because if the blue curve looks down, it will see the orange curve. So for this region 2, the top curve is blue one, f of x, and the bottom curve is the orange one, g of x. So you have to integrate f of x minus g of x, top curve minus bottom curve. Now how we can find the exact value of these intersection points? So you can see that the value of the function for these intersection points are the same. If you see this point, so the value of the function, the y value, is the same, and again the x value and y value are the same for the intersection points. So if we set f of x equals to g of x and we want to find x, then we will only find this 4 intersection point, because only at these points the value of the x and the value of the function is same. So we set this f of x equals to g of x from minus twice pi to twice pi, and we wanted to know what x is. So we got these 4 intersection points. So why we are integrating top curve minus bottom curve? So you should know this from the basic knowledge of integration. Say I am integrating only a function g of x from this left point to right point. What will we get? We will get the area under the curve. What is the area under the curve? The area under the curve g of x is the area between the g of x and x-axis. From this left intersection point to right intersection point, we will get this whole area under g of x curve. Now if we integrate f of x only from this left intersection to right intersection point, we integrated g of x earlier. So let's now integrate f of x. So if we integrate f of x from this left intersection point to right intersection point, we'll again get the area under the curve. So this time we will get the area under f of x curve. So the area between f of x and the x-axis. So if we integrate f of x from this left intersection point to right intersection point, we'll get the area under f of x curve. Now if we subtract the area under f of x from the area under g of x, what will we be left with? We will be left with the area of this region. That is why we subtract top curve minus bottom curve. Let's see the second region now. So for the second region, the top curve was the blue one. So if we integrate only blue one here, we will get the area under the blue one curve, but in minus, because the blue one is now in negative side of the x-axis. Let's assume we get minus 2 if we integrate the blue one, and we get minus 6 if we integrate the orange one, and then if we subtract minus 6 from minus 2, we will get plus 4. That is why here we are integrating the top curve minus the bottom curve, the f of x minus g of x. And for the third region is the similar as the region 1. We'll have to integrate g of x minus f of x. So after solving the equation, we got this 4 intersection point. This one is minus 4.2, the x value, and this one is minus 1.8, and this one is plus 1.8, this point, and this one is 4.2, this point. So let's find the area now doing the integration. So to find the area of the region 1, we have to integrate from minus 4.2 to plus 1.8. These are the 2 intersection point of region 1, and for region 1 the top curve is g of x and the bottom curve is f of x. So we have to integrate g of x minus f of x, and then we'll find the area of region 1, and then we have to find the area of region 2. So again the minus 1.8 is the lower limit and plus 1.8 is the upper limit of region 2, and for region 2 f of x is the top curve and g of x is the bottom curve. So we have to integrate f of x minus g of x for region 2, and for the third region we have to integrate from this point plus 1.8 to 4.2, and for region 3 the top curve is g of x and the bottom curve is f of x. So you have to integrate g of x minus f of x, and then if we add this all this area, we'll get the total area. So we added these 3 regions and we got 6.92. I hope you have understood now. See you in the next video.